Okay, question number 25, the last one on the paper. We're asked which is not a cause of energy loss in the transformer. Let's have a look at all four and see what it's going to be. A is good insulation between the primary and secondary coil. And there's your answer straight away. Because don't forget, your transformer kind of looks a little bit like this. It's kind of like a square core here. We've got a coil here, we've got another coil here, and the whole idea is that we send current through this primary coil, and then it's obviously an AC supply that we're sending through. That's going to result in a changing magnetic field through this one, which will be sent through this one. A changing magnetic field through here. We've got a change in magnetic flux, so therefore we've got an EMF induced in the secondary coil here. So good insulation between the two coils is no issue at all. The whole point of your transformer is that we transfer the energy via magnetic fields. There's no electricity that goes from P to S anyway. It's not supposed to. You don't get electrons here going into here. That's not how your transformer works. So for this one, it's pretty straightforward. The insulation is not going to affect it at all. Good insulation between primary and secondary coil, not going to be a source of energy loss. Just to clarify those other 3 points, induced current in the soft iron core, that is going to be an issue. So when I have an alternating current in this, I'm going to produce my changing magnetic field in here. That's going to generate EMF here, but it's also going to try and swirl the electrons round. That was supposed to be a swirl, it actually turned out to be an E, which is sort of fortuitous, I suppose. So they're going to spin round, basically. You're going to have these things, and then we call them eddy currents. These electrons just spinning round. That's going to take energy. That's going to be a waste of energy. That's why, of course, usually we laminate the core to kind of reduce those effects. Reversal of magnetism in the soft iron core, that's going to take energy as well. Don't forget, when I turn this thing on and it sends current one way, it's going to magnetise the soft iron core. When I send current the other way, it's going to try and magnetise it the other way. We've got to work against the fact that this iron core now has the wrong kind of magnetism, if you like. The magnetism is pointing the other way. We need to reverse that magnetism. That's going to take energy. So that's going to be a bit of a source of energy loss. And finally, resistance in the primary and secondary coil. That's a fairly straightforward one. The resistance is going to mean that these wires are going to heat up, and again, that's going to be linked to energy loss in our transformer. So the answer for that one has to be A. Well done on getting through that far.